Hello, I'm Atindra Chaturvedi. In the previous video, we worked very extensively on the ESXi command line in the ESXi shell and looked at the ESXCLI network command very extensively. In this video, we are going to look at the custom TCP/IP stacks. Managing custom TCP/IP stacks is now possible in version 6 because now on the command line, there is the ability to actually create new TCP/IP stacks. There are 3 stacks that are implemented when you install ESXi 6.0. You have the default stack that's used for everything else, and then there is the provisioning stack and the vMotion stack, which are initially not utilized. So one has to know that they exist to be able to use either vMotion or provisioning on those stacks. In addition, there is the ability to create custom TCP/IP stacks. So with that, let's move to our lab. We are now in the VMware vSphere web client, and I'm logged into my 192.168.0.201 server here. As you can see, it has 6 NICs that we will use during our course. Let's look at a few things here. Go to the Manage tab and look at networking. And what you see up here in the TCP/IP configuration is that there are 3 stacks defined: default, provisioning, and vMotion. And if I scoot this across, you can see that the default stack has one VM kernel adapter basically plugged into it, and there's a gateway IP address assigned to it, as well as if I move across, there is a preferred, there are some IP v6 and as well addresses as well as alternate and preferred DNS servers. So in the system stacks area, there are 3: default, provisioning, and vMotion. Let's look at default. By clicking on that, you can see that it has DNS, it has a routing, it has the IPv4 routing table, a v6 routing table, and some advanced configurations like New Reno and Cubic, and some maximum number of connections. So it's kind of a default setup for that stack. It's also called default. If you click on the provisioning stack, you can see there's nothing that's set up yet basically for that. And when the first VM kernel is actually plugged into it, that's when it becomes operational. The same thing with vMotion. When we set up a VM kernel for vMotion, we can define this TCP/IP stack. So you now have the ability during the provisioning of VM kernel adapters to specify, and so we're going to actually try and do that. I'm going to define a new VM kernel adapter, hit next, we select the standard switch, click next. Now when the new VM kernel is being defined, we have some other options available like the new TCP/IP stack, and you can define provisioning or vMotion. If you select vMotion, then the checkbox for vMotion is automatically enabled. If you check provisioning, then the checkbox of provisioning is automatically enabled, which means that these 2 stacks can only be used for vMotion and provisioning because everything else is grayed out. So I'm not going to go forward with this. Basically what you have to do is to put in the IPv4 settings. So you can either use DHCP or static, IP4 address and so on, DNS server addresses and everything else. So it's all the normal parameters that one would actually use. I'm going to cancel out of it because we are interested in custom. And to do custom TCP/IP stacks, we have to go to the command line. So here we are at the command line for that same system.201. Let's key in ESXCLI network IP and hit the enter key. And we see that we have now a command called netstack, which is operations having to do with the creation, management, and deletion of VM kernel netstack instances. So I retrieve that, key in netstack, hit the enter key, and now it tells me I have the ability to use the add, get, list, remove, or set, which will configure new settings for a given netstack instance. Let's just do a list first. It's always a good idea. And it shows us that there is basically the default TCP/IP stack. And the reason the provisioning and vMotion don't show up right now because there are no VM kernel adapters that are attached to it. So I clear this and we go and back to netstack, add, hit the enter key, and with a capital N and a string I can create a new netstack. So I say add -n and I say packed stack, a new TCP/IP custom stack for packed publishing. Now when I say list, I will see my packed stack already available there. Now there's nothing plugged into it, there's no VM kernel in it. Now the rest of the configuration obviously can be done from here, because if I say netstack, you'll see that one of the commands is to configure the settings for a given netstack instance, and we can actually try it out by hitting clear again, IP netstack, and then we say set, and it wants a parameter -n, and then it can be enabled, and here we go, a network stack instance, maximum number of connections. We saw that. Can enable it. There's a TCP congestion control, Cubic and Neurino, and we will talk about this briefly in this video as well. So I think it's time to go back to our client again and see what shows up in our web client. So we are back in our web client, and we will refresh that. And now you see that there is a custom stack section, and in there's something called a packed stack. I could click on that with a pencil. I can edit it. There's a name, the DNS configuration. So I can enter my preferred DNS server, 8.8.8.8. I can go to my alt DNS server, 8.8.4.4. Not going to complicate things with search domains, and I click OK. And I see that my DNS, there we go. It has been updated. Sometimes you have to use the refresh if that doesn't happen. Okay, let's look at editing now. The VM kernel gateway, there's nothing out there, so we edit that as well. We can add the routing configuration. The VM kernel gateway can be assigned for this, and then the advanced congestion control algorithms. Now there are two options available: Neurino and Cubic. Now the most interesting part of Neurino and Cubic is that these are two new congestion control algorithms. I will show you just briefly what they are. You can do the rest of the research yourself. So let me shift over to websites where this information is available. So this is the information for Neurino. The Neurino modification applies to the fast recovery procedure when you receive 3 duplicate ACKs, and ends when either a retransmission timeout or an ACK arrives. So this is basically it's an extension to RFC 5681, and this information is available here as an RFC. This is RFC 5681, and then it actually documents a couple of other things as well. And this is Cubic. The earlier algorithm was called BIC, but now it looks like they're using a Cubic function that goes like this, and this is used again to fast start and the new TCP mode here to fast start TCP/IP after congestion. So we can select our congestion control algorithm. It's a nice feature, because when congestion happens and you have to try and fast start TCP/IP, there can be significant delay. So these are good algorithms to actually use up here. Okay, so I will just maybe select Cubic and click OK. And basically that is how the packed stack is done. We are now back into our command line, and I will retrieve this and remove -n c KTSTACK, our custom TCP/IP pack stack. When I list it, I'll just see the default TCP/IP stack there again. So it's a very useful thing. Most of the work has to be done on the command line, but it does show up in the web client. So we just finished our look at custom TCP/IP stacks. We created a new TCP/IP stack called Tact Stack. We saw how when we create a new VM kernel adapter, the option to use that stack actually shows up at that point in time. We then look to see the various options that we could use for congestion control. There's new Reno and Cubic. Took a quick look at that as well. And then we went back to the command line to delete that TCP/IP stack. So with this, we move on to our next video, which would be working with vSphere 6 virtual machines, and I look forward to seeing you there.